Here's a crazy idea that might actually be true. A fungus that eats plastic. In 30 seconds, you'll know something 99% don't. Let me prove it before I sell you the dream. A few years back, scientists found a strain of Aspergillus tubangensis living on a plastic-choked landfill in Pakistan. It wasn't just chilling there, it was colonizing polyurethane, one of the plastics in foams coating shoe soles. In the lab, they put thin strips of polyurethane on agar plates, added the fungus, and watched hyphae, the little threads, crawl across the surface. Under the microscope, the plastic wasn't smooth anymore. It was pitted, cracked, and getting crumbly. Chemical tests showed the long polymer chains were being chopped into shorter pieces. In weeks, not decades, the plastic lost mass. That's not wishful recycling. That's digestion. The how is even cooler. The fungus secretes enzymes, think nature's molecular scissors, esterases, lacases. These enzymes snip bonds in the polymer, making fragments small enough for the fungus to pull in for energy and growth. It basically turns dead plastic into dinner. And it's not a one-hit wonder. Another fungus, Pestalozziopsis microspora, can chew on polyurethane even without oxygen, which is huge for buried waste. So the concept is real. Some fungi see plastic as food. Okay, proof established. Here's the payoff if we don't mess this up. Imagine modular mycoreactors next to landfills and shoe factories. You feed them foam offcuts, old soles, mixed polyurethane scraps. Inside, precisely tuned conditions, warmth, moisture, pH, let the fungus do its thing. Out the other end, harmless breakdown products you can root into biogas, soil-safe amendments, or even feedstock for new materials. Think coatings and adhesives too. Polyurethane is everywhere, in couches, car seats, insulation boards. Instead of trucking this stuff across states to incinerators, you drop it into a local fungal digest. Fast cycles, low energy, minimal sorting. Microplastics? Fungal enzymes could be built into filter cartridges for washing machines or storm drains. Capture tiny bits on a mesh, bathe them with enzyme cocktails, and reduce what flows into rivers. Better yet, manufacturers could design fungus-ready plastics, same performance, but with chemical bonds that enzymes can easily grab. When you're done with the product, it's not trash. It's feedstock for a biological loop. That's circularity, not wishful recycling. Now, reality check. Field scale is hard. These fungi love specific moisture and temperature. The plastic has to be accessible, not laminated into 5 other materials. We need to make sure the end products are safe. No toxic additives sneaking through. And yeah, you don't want to release a hungry fungus into the wild and hope for the best. This is controlled, contained, and engineered. But the path is clear. Optimize the enzymes, run pilot reactors, link them to real waste streams, and design plastics that cooperate. Nature already wrote the code. We just have to copy it smartly. A fungus that eats plastic isn't sci-fi anymore. It's a blueprint. If we prove it at scale, the payoff is a world where plastic stops being forever. Chime in now. Like and subscribe for more.